Motunari, are you there? Okay. Guess they are not available. So, before we proceed, based on the class we've had last week and from your research, is there anybody that has questions or something that needs clarification as regards our last class, or there was something you come across while reading and discover like it's a bit confusing and you like to get clarification on? You can ask those questions on before I proceed with today's class. Is there anybody with questions from our previous classes? All right, take that as no. So this week we are going to look into, okay, Emanuela, you can speak.
All right. Good evening. Good evening, everyone. So, I'm sorry, can you hear me?
Yeah, I can hear you.
Okay. All right. So, I regarding last week's class, I just have a bit of confusion with Ethereum virtual machine, like you mentioned last week. So you said it was like the EVM is like a CPU that powers blockchains. I think blockchains or cryptocurrencies that are built on Ethereum blockchain, if I'm not mistaken. So, well, I'm just trying to find out what about other cryptocurrencies now that exist on other networks or on other blockchains rather. Like let me use Algorand for instance. So, does it mean that Algorand now should have its own kind of Algorand virtual machine or probably another name, but like basically another CPU that powers stuff like that?
Okay, let me put it the way this to correct something you just said. The EVM basically is a virtual machine, and this EVM is what handles execution of actions of state transitions on Ethereum as a blockchain. So, like, I understand that what brought a lot of people into the world of blockchain is cryptocurrency, but cryptocurrency is basically a fraction of the limitless possibilities available to you on the blockchain. So for other ecosystems, they will have their own model, likely a virtual machine also to handle their own execution. So it varies as it relates to Ethereum. What handles those execution and transition of state basically is the EVM. When it comes to other blockchain like Agorand that you mentioned, if you look deep into it, I think Agorand, you use Rust to build on Agorand, if Rust or Python, if I'm not mistaken. So they have their own execution. And the reason why it is like EVM is that once I know what I'm about to explain might be a bit confusing now, but we are going to come into this probably next week. So the reason why you have the EVM is because normally your PC, your systems understand binary, which is zeros and one. And these binaries are a lot of very difficult for humans to grasp. So for example, now let's say, sorry, who answered that question? I think, I can't remember the name of the person.
Me, Emanuela.
Okay, so let's say Emanuela now, if I am to like process your name onto the EVM, it's going to be filled with numbers and alphabets. And it will be very difficult for me as human to understand it. So because computers their own word, which they understand, there needs to be a way for the human world to be able to communicate what we want to do with the system. So you write it in a programming language. So this programming language affiliates to like EVM now, you are using Solidity. Your Solidity code is not actually what gets directly executed on the EVM. Your Solidity code is being compiled down to byte code. So it's those bytes code that are generated from a Solidity code that the EVM acts upon. I hope that's not confusing, but if it is confusing, we're going to come into that. So basically, that's how it works. I hope that answers your question, Emanuela.
Yes, yes, yes. Because I think I understand it a bit now. Thank you.
All right. Any other person with question?
Hi,
No
hi,
question?
yes, I have a
Okay.
question.
All right.
But can you hear me?
Yeah, I can hear you.
Yeah, I said is regarding the types of nodes. I don't really understand that full node, light node, etc. And then when I was doing my assignment today, I saw that types of account on Ethereum. I think I logged off early last class because of network issues. So I don't know what are the types of accounts really. I don't know them. Thank you.
All right. Okay. Last week, so even if you miss like the live class, as much as possible, try to make use of the curriculum material shared with you. Everything you need is actually there. And if like this thing, don't wait till when you are in class to get clarification on some stuff. So you can drop. That's why the Slack channel has been there. I was just checking through the Slack channel today, and I saw like probably the only time the Slack channel has been active is when an information is about to be passed across. And I don't know why it's like that. You guys, that is your avenue. You have it for this next 4 weeks to ask anything that relates to like what you are covering. So make use of that. So as it relates to the node, we have the full node, the archive node, and stuff. So the full node, if you want to like be a miner, like you need the latest, you need to be up to date with your transaction history, with the transaction that has been executed on the blockchain. So, and in doing that, you need history back to when everything was created. Yeah. So this is what's going to enable you to like be able to like add transactions to the blockchain. So you can go to Ethereum book, the Ethereum developers, there's a link there that I posted last week that covers this type of node. So you can just go there to like get more info about this. And I explained last week. Did I explain the two types of accounts last week? Can anyone remember? What are the two types of
Yes,
accounts you have on it?
you said
So what are they?
contract accounts and externally owned accounts.
Yeah, you did.
Okay. So what's the difference between
Contract
those two
owned
types of accounts?
accounts cannot carry out transactions. They cannot initiate transactions because they do not
Contract
have
and
private key. But externally owned accounts are the kind of accounts that we have that we can use
yeah.
to carry out transactions. It's an account managed by a human being, not a contract.
Okay. All right. That's cool. So sorry, Shally, does that answer your question now?
Okay, yes, I get. Can you guys hear me?
Yeah, I
Yeah,
can
I
hear you.
understand what externally owned account is, but that contract, I don't fully get it. I don't get what she explained. I get that externally owned is the one we have where we have I think private keys, passphrases, stuff like that. But then what's contract account, please?
So the contract account, how they are created is when someone sends the transaction to the blockchain, and included in that transaction is like codes to like create a new address. So like we are going, what we'll be doing most of the time as smart contract developers, blockchain developers, would be to create smart contracts, which are these contract accounts. So because these accounts don't have private key, everything that handles the logic, the how people interact with those contracts are stuff that you must have written in Solidity codes that needs to be executed there. So like we are going to come into that, so but into details about smart contracts. But that's just basically how it was. Contracts are generated from a transaction to like create that has code attached to it. So since we are analyzing blockchain transactions and wallet today, it's going to be more clearer for you. Yeah.
Okay.
Shally, I will.
Yes, yes. Thank you.
All right. So, any other question from anybody before I proceed? All right. So today we'll be looking at a blockchain transaction. So before I proceed, what do you think is the difference between carrying out transaction in normal world and carrying out transactions on blockchain? Anybody, you can unmute your mic, you can drop it in the chat section.
I think maybe because on the blockchain, the transaction cannot be traced back to you, like the person's name or something like that. Then, but in the real world, it can always be traced back to you.
Okay. All right. That's cool. Any other attempt? Emanuela?
Right. I would say that another difference is that in normal transactions we make use of bank accounts and fiat currencies, while blockchain transactions we make use of wallets and cryptocurrencies.
Okay. All right. That's cool. Thank you. So the blockchain is peer-to-peer. Can you expand further what you mean by that as it relates to transaction? Tell me.
So what that means is, if I'm sending money to, say, Emanuela, I'm sending it to her directly. There's no intermediary. There's nobody in between that I will send it to that wouldn't, send it to Emanuela's bank or anything like that. It is directly. I am in charge of the transaction. I'm in control of that transaction. Also, the record of this transaction is open and it's public, unlike in the bank where it's probably only known to the bank and to me when I request for my statement of account. This time around, it is open to everybody in that network. I think that is what I know. Understand.
All right, that's cool. Thank you. So let's move into it then. So transactions basically are cryptographically signed instructions from accounts. And when we talk about cryptographically signed instructions from accounts, it has to start from the externally owned account. We understand how cryptography works by now, and this transaction has to be like cryptographically signed. That is making everything, hashing everything together to ensure that privacy is still being maintained and the integrity of the data are intact. So how this works is that an account will initiate a transaction to update the state of Ethereum network. So the simplest transaction is now like transferring ETH from one person to another. Let's say I want to transfer more ETH from Emanuela has ETH and she wants to transfer it to sorry, let me use the name of people in this class. So let's say Judith. So that's how that's the way it works with transaction. So this transaction now, if you remember quite all right, in our last class, I said the transactions will always be initiated by an externally owned account. The originator of any transaction can never be a contract account. That is the person that starts the transaction. So at every point in time, the context of the person calling that contract, calling a function can change in the sense like probably you are performing like actions that require you like interacting with different contract that's already been deployed. So at every point, like when you are in this contract, the message sender might actually be the contract itself. When you move to another one, in that same transaction, the context of that message of sender might change. But this global variable, which is TS origin, will always be an EOE. And why is it like that? Let me see if everybody understands. Why is it that contract accounts cannot initiate transaction? You can drop it in the chat. You can unmute your mic. Or do you guys want him to start calling names? Why do you think contract accounts cannot initiate transaction? I've explained this in our last class. Okay. From the last says because they don't possess a private key. Is she correct? How many people agree with her?
I agree.
Okay. Ose, what do you want to say?
I agree with her.
Okay, you all agree. All right, so that's basically the reason why yes, she's correct. That shows that we're all following. So the reason why they can't initiate transaction is because they don't have private key. So basically, what are these transactions? So these transactions are action initiated by an externally owned account, from what I've explained now. In other words, an account managed by human. This is not accounts controlled by codes now. So, and you remember in our last class, everything I've been saying will be built up on what we've learned in last week's class. You remember we said like the Ethereum virtual machine blockchain works as a single thing, as a single global computer, which has a state. And because they are distributed system, they need to have a state. And this state, every right transaction gets to update the state of the blockchain, the state of that ledger as at that point in time. So when you are making transaction to transfer money between one party to another, you want that transaction to be recorded on the blockchain. That means that that transaction needs to be added to the list of transactions already available on the blockchain. And that's state changing. So because this is state changing, that's why you need your private key to sign this instruction. And that signature that you apply, that you append to that transaction will be verified in relation to your public address to verify that, yes, truly, this is the originator of this transaction. And if everything goes well as it's supposed to be, then your transaction will be added to the blockchain. And as at the point of adding it to the blockchain, it can no longer be removed again. Are we all on the same page?
No, please, can you go over again, please?
Okay. Which parts do you not get?
The part where you were explaining why the contract cannot initiate transactions on the blockchain. Where you're talking about the keys.
Okay. So what I said was that for transactions on blockchain, you need your private key. It's private. It's not meant to be displayed to every other person. So what is the essence of private key? Private key are to make your account secure, and they are to you are to make use of them when you want to sign transaction. So like, like when you want to, because the blockchain, once a transaction has been added, it cannot be removed. That is why you need to verify that the person that is sending this transaction, even though you don't know the name of the person, does it correspond to the person that owns that public address? Does the private key corresponds with the public key? That's why you need that. Is it clear?
Yes, thank you.
Okay. Okay. What's the difference between an Ethereum address and private key? Anybody? Oh, sorry, you can speak.
Okay, I think the only thing I know is concerning the Ethereum address. I think all Ethereum addresses begin with OX, something like that, if I'm correct.
So what's the difference with private key?
The Ethereum address is public. I don't know if I'm contradicting myself based on what I understood from what I could grab from the reading. I think the Ethereum address is generally a public address, but the private keys, as we have already known, is privately owned, based on my understanding. I don't know if I'm correct.
Okay. All right. Any other attempts?
Okay, the Ethereum address is just like your account number. When you want to perform a transaction or you want someone to send you something, you tell them your address. It's not necessarily public if you don't make it public. If you don't send it to someone, someone cannot automatically know your Ethereum address. But your private key is used to secure your account or even recover your account. You can provide your private key, and sometimes they go further to your phrase keys, then you can recover the account and keep it secure. So when someone wants to like take control of your account, if they don't have that private key, they can't have access to it.
Okay. All right. So there's a part you need to understand that your public address is related to your private key. So if you look at the way addresses are being generated, there are some articles I dropped for you guys as relating to that. It goes through different cryptographic measures to ensure that you get those numbers and those addresses. Those numbers and addresses, they go through a computational process. And if you change any of them, it will not be valid. Let's say somewhere that's supposed to be like a small letter A, but because you want to try and see just guesswork, it will not work because we have something and relating to that we call checksum. So checksum basically allows you to like maintain that those addresses that you've generated are well generated, so that as to prevent private collision of signatures. So this Ethereum address, the way it works, how it relates to your Ethereum address is the same thing as your public address. And this, yes, Fatima, that's correct, checksum. So this Ethereum address basically is your public address. But from your public address, when you use it to sign a transaction, when the verification process is happening, they should be able to tell that, you know, like when you're sending your transaction, your public address gets broadcasted that this address is the person that initiated this transaction. So they need a way to verify with this public address that you have as against your private key to check that it is actually the private key that signed that transaction corresponds with that with that public address. And in this process, your private key is not being revealed. So that's why when you sign, I'm not going to go into details of that. When you sign a message.
Sorry, please, I didn't hear you. You said your private key is not being.
Your private key is not being exposed in the process of verification.
Okay.
So like it is not your raw exact private key that's been displayed to miners when they want to like verify that that transaction was actually initiated from the address. So at every point in time, your private key is kept private while you are making transaction. The only thing that can make your private key exposed is when you give access to people. People were able to like get access to your private key, or you probably use a phishing link, you sign a transaction and stuff like that. But in an ideal situation, your private key should never get exposed. Are we all on the same page?
Yes.
Yes, sir.
Okay. All right. So we can proceed now. So um when you send out this transaction, the transaction needs to be broadcasted to the whole network. Everybody on the network needs to like see that transaction. And when this happens, the miner will execute the transaction and propagate the resulting state change to the rest of the network. So the difference between when you are sending transaction on the blockchain and in the traditional world is that any state change you are performing on Ethereum and other EVM chains make cost gas. You are paying fee for them because it is this gas fee was used as a mechanism to solve something. I just hope you are all curious enough and probably have the answer. Why do you think you have to pay gas fee while performing transaction on blockchain? What led to the invention of using gas? Is there no better way to like, why do I necessarily have to pay on an open blockchain? Anybody? Let me see. Why did we have gas fee mechanism in place? Judith.
Gas fee is what that is used to pay miners. Gas fee is used to pay miners, I think. I don't know.
Why do you have to pay miners?
Because of the mathematical algorithm they solved by validating the new block.
Okay. Yeah. You are close. That's part of the reason, but that's not the major reason why gas fee mechanism was brought in place. Because, for example, now from your explanation, if you're on a proof of stake network, you don't need to pay miners.
Yes.
So, but that's part of that's correct. I just need more opinion on that. So, Ose, yeah.
I would say gas fee is because it's so as to reduce the number of transactions that go on the block per time.
Why do you
Like-
need to limit the transaction that goes on the block?
For my own opinion, this one is my own opinion. I would say so that the most important transactions are executed. Like if somebody really needs a transaction, no matter the gas fee they will pay it. I really understand that Ethereum has high gas fees. So I would say if the transaction is important, it's to prioritize transactions basically.
Okay, to prioritize. You said important transaction. Since we say it is a decentralized network, what makes a transaction important?
Please, I cannot answer. I don't know.
All right, that's good. Thank you. Fatima, you raised your hand before. So
Yes. Also, I was thinking what Use just said now. Yes,
okay.
to prioritize the transactions on the block
We are
because there are
saying
sometimes that
okay.
yes, there are sometimes that people just play around, like you just sign up on, like download a new wallet, and some people have more than 5 wallets and there's no money there. I just want to test how blockchain works and all of that. So when there's this gas fee attached, it would kind of the miners would work on the most important ones first before considering people that are using it for sample instances. My own is just priority, just to reduce the transactions so that it doesn't get clustered. And
Okay. I get where you guys are coming from. Just for the benefit of everyone here learning. About 2 people that have answered now mentioned important transaction. And we described earlier that in blockchain that it is decentralized, anybody can participate. When you're not saying important transaction, are you not saying that because I don't have money in my wallet, I'm not important to the Ethereum network? It's supposed to be available to everybody, right? So why is it like that? Ose, yeah.
Let me make a simple instance for me. There was a time I wanted to buy a particular token,
Okay.
but when I realized that the gas fee I used to buy it, like from Ethereum, I'll have the token first in Ethereum. From Ethereum, I'll not was it conversion or whatever to the token that I actually wanted to buy as at that time. I was like, God, if I have this money, I'll not be where I am now. So I just killed the thoughts. Basically, it's just what it is. It's priority.
Yeah, okay. All right. So here is it. Everything you said, all of them are valid. But I want you to know this. There's a reason, apart from like people adding volumes of transactions on blockchain, the major reason why you have gas fee mechanism was to solve the issue of halting. Halting spells HALTING. If you've been in the Web2 world, I expect like majority of people in class here have like interacted with Web2 technologies and stuff. You've encountered this thing called DDoS, which is distributed denial of service. So gas fee was a mechanism used to mitigate DDoS on blockchain. You know that every state change has to like be broadcasted to everybody. So in order to make this thing more distributed, such that one person will not just say, because I'm a rich person, like I know a lot of us have been annoyed with this kind of issue. You probably go to ATM, you want to withdraw. Maybe you probably just want to withdraw 10K, and someone is just withdrawing. And there you'll be like, why is this person like this? I just need to like move out my money and just leave. And this person, and the funniest of the cases is probably when you now get to your turn and you discover like the ATM is now empty. Has any one of us experienced this kind of issue?
Yes, numerous times.
So like this is like actually a denial of service, where one person takes the whole resources that is supposed to be made available to everyone on the network, and it is now available to one person. So in order to limit, this also happens on web, and this can be an attack. So an attacker can actually do this denial of service. So in order for Ethereum and blockchain to mitigate this, that's why you have gas fee. So this gas fee is since Ethereum is Turing complete, it can handle any complex computation you hand over to it, as long as it is computationally feasible. So this gas fee mechanism was placed there such that you prevent denial of service. Since everybody has access to it, let's not make it that one person will just take the full resources available. Like if one person now has this thing, all the resources that are supposed to be available to the whole network is now one person, one transaction that's taking it. Other transactions will be delayed. That is why you have gas fee. And for every gas transaction you are performing, there's a gas limit for it. For example, on Ethereum, when you are trying to like perform a transaction that transfer money from one person to another, the maximum gas unit you can use is 21,000 gas units. Anything above that, the Ethereum machine will reject it, because it has calculated all the computational processes that it's supposed to like go through and say that no matter how the case is, you are not supposed to spend more than 21,000 gas units. So that's it. Gas fee is to mitigate the halting problem and prevent denial of service. Is that clear now? Ose?
Okay, can we now say that one of the purposes of gas fee is to enhance security?
Yes.
Okay. Then I also had a question. I don't know if this question should come in here, but
is it on gas?
It's not really on gas, but it's
Oh,
on Ethereum
block.
chain.
Calm down. On block,
Okay.
we are going to go over block in today's class. So
All right, thank you.
let's put it there. So that's it. Any other question? All right. No question, right?
Hi, I have a question, but I'm in a bus, so I don't know if you can hear me.
I can hear you.
See, I'm asking how exactly does the gas fee work? Like the gas fee, right? Like let's say you want to make a transaction of $50 on the
Mm.
Ethereum network. Sometimes the gas fee is even up to like $32. Sometimes for real, and like that's like ridiculously high, and I don't know. So the money, that $32, what is it? Where is it going? Like, is it going to other people's wallet? What's going on with it? How exactly does it work? That's my question.
Okay. On your this thing, I'm going to come to that as regards like the calculation for it. But you should know that just like the when you are writing your code on Web2 platforms, you don't care about each line, the cost of each line of code. Most of the time, what you are interested in as relates to like data structures is basically the time complexity. But in Ethereum now, every single transaction, every single line of code, every single function that is going to be executed by a user has some gas fees attached to it for it to be executed. So in terms of the calculation now, we have gas fee, we have gas price, we have gas units. We are going to cover everything as relating to that in today's class. So just hold on. Let me continue with the class for now. I'm going to answer it after, like, once before the end of today's class. If the question is not clear, you will just ask me again. Yeah, that's it. Is that all the questions we have for now? All right. So transactions require a fee and must be mined to become valid. So a submitted transactions include the following information. So for every transaction submitted, there must be a recipient, that is the targeted address. So if it is a transaction to transfer money now, it has to be, okay, I'm transferring from, let's say, Judith to Uchechukwu, Matilda. So that the recipient in this case now, let's say the person sending the money is Fatima. So the recipient will be Uchechukwu, and that must, and how you are representing this is by using the address. So if it is to interact with a contract now, the recipient will actually be a contract. Let's say you want to deposit into a staking contract now, the recipient will be the address of the staking contract. So basically, look at it now. If the receiving address is an externally owned account, value will be transferred. That is the money, either the token, either the Ether, will be transferred to the person. But if it is the recipient is a contract code, it's a contract account, there has to like be a function you call on the contract. So, and that transaction will actually execute the code on the contract in relation to what you are sending. The next thing that must be attached to a transaction is signature. So the signature is the identifier of the sender. This is generated when the sender's private key signs the transaction and confirms the sender has authorized this transaction. So when you are signing, you are not only signing, you are not only appending your private key. You are, let's say, I want to transfer 5 ETH to this thing, to Fatima now. So what I am signing will be transfer 5 ETH to this thing. Everything will be concatenated together and cryptographically hashed. So that is what you are appending your signature to. The next one is nonce. So nonce basically is an incrementing counter which indicates the number of transactions that has been approved number of transactions that has been executed from an account. So if you have a fresh account now, like your MetaMask, you've not performed any transaction there. Like on the network now, let's say your MetaMask account, you've not interacted with Ethereum minutes, your current nonce will be 0. If you perform 10 transactions, your current nonce will be 10. So nonce is to indicate the number of transactions that has gone through and that has been executed from an account. Because all these things combined together are part of the things that forms your transaction hash. So the next thing that attached to a transaction is amount value. So this value basically is the amount of ETH to transfer from sender to recipient in the value of the denomination of ETH. So it varies on blockchain now. So if it is Solana, the value should be this thing will be in Sol. If it is Polygon, the value will be in Matic. So the other alternative that's there is data. So data feed is the optional feed for arbitrary data. So as you are sending transaction, you can append additional data to the transaction you are trying to add to the blockchain for it to get executed. So this is the feed where it's going to be added. So, and the next thing is, so after this part, I'm now going to cover some stuff as relating to gas. So we have the gas limit. So this is the maximum amount of gas units that can be consumed by the transaction. Maximum amount of gas units. So for each transaction you are carrying out, there's a gas unit. For example, now someone asked the question about you're trying to make a transaction of $50 and you're paying high gas fee. What the Ethereum is saying is not that dollar value. What the Ethereum understand is the gas unit. So how you get gas fee is by multiplying the number of gas units used for a transaction by the current gas price. How you get gas fee is multiplying gas units with current gas price. So at every point in time, gas price can vary depending on how many people are interacting with the network at that point, the number of congestion on the network, all those things calculated together are what determines if you are going to pay a higher gas price or a lower gas price. So, and the next one is mass fee per gas. So this maximum fee per gas is the maximum amount of gas willing to be paid for the transaction. So like, for example, now when you're initiating transaction on your, on what's it called? On MetaMask, for example, it gives you option, like it gives you the normal price and it gives you like the increased price where you can adjust so that your transaction can get processed faster than normal. So that's where you have the gas fee. So before I go to gas, I will have to like give you guys explanation on what's it called, on gas price. So what is the smallest unit of Ether? Let me see.
Wait.
And how many decimals is it?
10 raised to power minus 90.
Is that?
10 raised to power minus 9.
No, that's not correct.
Okay, that's great.
Yeah, that's GA. So let me just show you guys. I added this to the what's it called? To the resources, but I doubt if most of us have gone through that. So this is on GitHub. So you can go to where is it? I think intro. Yeah. So try as much as possible to go over this Ethereum basics. So this the minimum, just like the way you have naira, and you have kobo, you have dollar, and you have cent. 1 ether, the smallest value of an ether is wei. And 1 wei will give you, 1 ether will give you 10 raised to power 18 wei. So that's what's explained here. So try as much as possible to come back to this and read through, because I'm not going over this because we don't have we only have 4 weeks, and at the end of the 4 weeks the goal is for you guys to be able to write some smart contracts. So but you need to like focus on this thing and like build on it. So this is it. You have wei, you have kilo wei, and all this long stuff, Zabo and stuff. So these units, these denominations that you are seeing are what are used in calculating the gas units you use. So your gas units are being calculated in wei. So this is what you use to like get the number of this thing you are going to like use for your transaction. So let me come to Etherscan and like explain some things there. So we are just going to pick any random transaction. So let me pick this transaction. So from what I explained earlier, I said there are different like stuff that should be attached to a transaction. So this is the this is the person that sent this transaction, this address that I'm hovering on. It sends this transaction to this person. Look at it. This person transferred this amount of ether, $74. And what's the transaction fee? 0.54. So that's the, look at it. As I hovered on it, look at the calculation. Maximum fee per gas multiplied by gas use. That's what gives you this amount of ether, which is equals to 0.54. So this word in equivalent in dollars is for humans like us to understand. But this 0.00 something ether is what the Ethereum recognizes as like the gas fee that was paid. It uses it in relation to ether. And because ether is a very big stuff, that's why it has to like be converted to like wei. So like, look at it now. This is the gas price. 16.27 GWh. This is 16.2 something times 10 raised to power 9 wei. If you want to get it in terms of like wei. Wei is 10 raised to power 18, GWh is 10 raised to power 9. So the next thing is, you know, like as I explained earlier, there's a gas limit for transactions you are performing. So because this is a transfer transaction, that is why you are seeing the gas limit here to be 21,000. So this means that this 21,000 gas unit that was used to transfer $74 worth of ether, as at this point, costs $0.54. If it were to happen at some other point, it might actually be lower, or it might be higher. For example, on some days when the block gets really messed up, that there are lots of transactions, you can pay as high as $50 to move $74 worth of ether. So, and if you look at it, this is the gas fees calculation. Priority gas fee. This is the additional amount you are willing to pay for the miner, so that your priority is that you are increasing the amount that should be removed from your account. Like, let's say the normal price for this thing for transaction is $5. So you can say like, okay, at most, so I'm willing to pay $6 or $7 to perform this transaction. And if in case like when there are a lot of congestion on the network, the one with the $6 will get picked first. So that's basically how it works. I hope I've not confused us. So if you have any question on transaction, gas price, you can ask them before I proceed to block. Or are we all on the same page? Sally, I don't understand. You are dumbfounded. Like, it's confusing. Ha. Ha. And you guys, okay. Oh, yeah, okay. Oh, yeah, let's start working our way up from there. Which part is confusing? Which part is confusing? See, I've said this, don't make the mistake of saying you read later. Try as much as possible to understand this concept in class. That's why I advise, like, before we start our class, go and read so that at least as let's say, even if I'm saying nonsense in class, you'll be able to bros, you are saying nonsense. It's not the same as what I read usually. So that's it. So let me know actually where it's confusing to you guys. Also, you can speak.
Thank you so much. I didn't get the part where you mentioned the $60 will be picked first. Are you trying to rate how transactions are being selected per time on the Ethereum network?
Okay. All right, I'm coming. So to answer your question, like your gas fee that you're paying, it gets the gas fee gets rewarded to the miner. So, and you as humans, you will likely go with the one that's more profitable at that point. So when you send out your transaction, before it's been added to the blockchain, it's actually stored somewhere called the mempool. So this mempool is the storage for unconfirmed transaction. And this is where the miners perform their work. So the miners will see the transaction you are performing, they will see the gas fee you attach to it. That's why that maximum priority gas fee is actually essential. So that when the miners see, this is the amount, okay, I see something, a transaction, I see one that is the $10, the one that's $8. I likely go for the one that's paying $10 transaction fee because I know that's the reward I'm going to get. So is that clear, Ose?
Yes, it is. Thank you.
Okay. Please, if it is confusing, please ask question. Ask question. That's what I'm
Sorry,
doing.
I have a question. Like with what you just explained, do you mean like when you initiate a transaction, you said it is pushed to the main pool?
Yes.
Main pool, or
Yes.
so is it like it's a queue? The transactions are on a queue.
Yes.
If you use the normal amount, if you have to wait for your turn, but if you increase it, like you add that max fee per gas, you increase it, you add a little, the miners
So
can now move yours to the top.
yes, so you have more chance. So just like I said earlier, the mempool is like a storage of unconfirmed transactions. So every transaction is sent to the blockchain before it gets added, goes to the mempool. So the miners are the one that approve and add your transaction to the blockchain. So they just see and just so it is not like if your transaction, the gas fee you attach is low, it's not like it will not be added, but it might just take a while on days where the network are congested. But if it is, for example, now this transaction that we looked at is 0.54 and this thing. I think I made a transaction like about 2 days ago that was about like $100, and I paid up to like $5 as a transaction fee because I think I did it in the morning then. So like this one was done some 45 seconds ago. That's like 454. Okay. So that's why it's like that. I hope that's clear to you, Matilda.
Yes, it is. Thank you.
Okay, Romola, I was following you until I started seeing GWay and then calculation of gas fee, I think. Okay. Okay. Tomorrow is Thursday, right? Okay, but firstly, Romola, it's not that confusing. All what you just need to do is like get through read it. So like if you look at it now, what's the gas used for this transaction? I'm coming. Okay. If I go in details into this, it might actually be a bit confusing. So what I will say you guys should do is the link I went through, that's Ethereum transaction, that Ethereum book. You guys should go through it. And sorry, yeah. So this chapter 2 on the Ethereum book, you guys should try and go through it. And if you now have question on that, you can ask me. So like honestly, I've said this before, because you have limited time doing this transaction, this course, it's just 4 weeks, and that's pretty small to like go in depth about like blockchain development and blockchain. But since it's just meant to be like intro for you, so that's why it's like that. So just if you read, just try as much as possible before our next class, go through those resources I share. So if by Thursday, our next class is Friday, right? So if by Friday I notice like there are some issues, so we can actually have a makeup class before the next class. That's no problem. I can organize another class just to clear some doubts you have. So any question? You guys say you are confused, you are dumbfounded, but you guys are not asking question. Tell me, you are not asking question. You just said I'm founded dumb. Oh, which aspect is confusing? Like I've explained now. If you don't tell me the aspect you're having issues with, I will not be able to like pinpoint the area. So that's it. No question, Abby. Can you hear me now? Hello, can anyone hear me?
Yes.
Yes, we can hear you.
Yes.
All right. Okay. So blocks basically are batches of transaction with a hash of the previous block. So to minimize like this thing, let's just copy this so that we see how it works. Okay.
This is a blockchain demo.
Can you guys hear me?
In a very
Hear
visual
the
way, though,
sound?
make it very easy to
Yes.
So let's just go through this.
understand by stepping through the key pieces of what a blockchain is in a visual way.
Sir, the video is paused, so it's not playing anymore.
Sorry, I had network issues. Can you hear me now? Don't know why network is messing me up. So I just dropped the link. I don't know why network is messing up. So I will drop the link also in the Slack channel so that you can go over it. But let's just proceed with class for today. I don't know why network is delaying. So basically, before I go into details of all these things, your transactions, see them like when you want to arrange something in like a container. Let's say you are trying to like arrange biscuits now. You have to like, let's say in cases of cartons that can contain about 48 biscuits, it has to be complete of 48 before you can close that carton and start with another one. So that's the same way block is. So block is made up of transactions. So your transactions are bundled together into block. So these blocks are linked together using cryptographic hash. So I think probably we should have another makeup class tomorrow, or maybe our class on Thursday might be a bit longer. So let's just do it like that. If what I'm trying to explain is a bit confusing. So the blocks are majorly used to preserve transaction history. So, and these blocks follow order. And every new block you create has a reference to the previous block because it is blockchain. Each block makes a reference to the previous block before it. That's what's being referred to as like the parent block. So, except in rare cases, at any given time, all participants on the network are in agreement with the, sorry, I want to confirm something. Okay. So once a block is put together, mined by some miner on the network, it is propagated to the rest of the network. All nodes add this block to the end of their blockchain. Each of the mining nodes have the current state of the blockchain, and in order to propagate it to everybody, once a block is being mined, just like the same way your transactions are mined, once a block is being mined, the miner will broadcast it to the network, and the nodes will now append that latest block to their own end, to the end of their own blockchain, and the mining will continue. Just like the same way your gas fee goes to the miners. When a block is being mined, block rewards also goes to the person that mined that block. So the exact block assembly mining process is currently in use in Ethereum's proof of work protocol. So this concept of mining block is effective on a proof of work consensus. If it were to be proof of stake, it would be different. So basically what's included in a block, you have the timestamp, which is a global variable that integrates the current block you are in. And you have the block number, which represents the length of the blockchains. You have base fee per gas, which is the minimum fee per gas required for a transaction to be included in the block. So each block has a different base fee per gas. You have the difficulty. So this difficulty is what the miners attempt to solve. This is the effort required to mine the block. You have the mishash, you have the parent hash, you have transactions, which are all the transactions bundled together to be included in a block. So you have the state roots. So this state roots, the good thing about it is that it has the entire state of the system. Account balances, contract storage, contract code, account nonces are all inside. So that's the state root. And you have the nonce. So the nonce in block is different from the nonce on your externally owned accounts. So the nonce in block now is a hash. That's when you combine it together with the mishash. This mishash is the unique identifier for a block. So you combine this nonce together, this hash of the nonce, combine it together with the mishash. It will now prove that the block has gone through proof of work. So this hash is random. And so when you combine it together with the mishash, you use it to solve the block difficulty. And this is to ensure that that block has actually gone through proof of work consensus. So that's it. I am open to taking any question from now. So you can ask your question on transactions, on blocks, everything that's not clear, you can ask them. Can you guys hear me or no question?
We can hear you.
Okay, is that you don't have question, Abby? Or it's confusing? Jose, you can ask your question.
Please, my question is very vague. Can you please go over blocks again?
I should go back.
Go over blocks, like you were talking about what's
Okay.
in the block. You were making a reference to the hashes and those contents. Please just go over it again.
Any other person?
Thank you.
Any other question? Okay, so basically, this let's look at it directly from Etherscan so that you can see how it is being implemented in real life. So this Etherscan. So Etherscan, we've covered Block Explorer before. Etherscan is a block explorer. So let's look at these latest blocks. So let's look at the one that was mined in. Look at it. This one, 10 seconds ago. This is the miner. This Ether mine is the person that mined, is the miner that mined this block. And how many transactions are included in this block? You have 389 transactions. And these 389 transactions were included within 21 seconds. This is the value of transactions in this block. This is the block reward. So this Ether mine got 2.10142 ETH for mining this block. So if you look at it now, let's look at it. So you have the block height. This is the block height of the current block, the block that was mined. This timestamp is what I explained here as the timestamp, the time when the block was mined. If you compare it to what we have here now, sorry. Oh. Oh, sorry, I'm using Greek. So if you combine it together with what's here now, you can see the timestamp 1 minute ago, and this September 14, 2022, mined at 5:18:05 p.m. at UTC. That's it. So transactions, it has 389 transactions and 165 contract internal transactions are included in this block. This is the miner. This is the block reward. The person got 2.10 ETH. This is the block difficulty. Total difficulty size 178,222 points. And this is the total number of gas used. It has 100% gas target, gas limit, and base fee per gas. So the base fee per gas for this one is 21.4 something GW. Just like as I explained earlier, each block has their own like this thing, base fee per gas. Let me just look for any other one. So looking at this, look at it. The base fee per gas for this one is 21,47498. This one, okay, it's almost similar, but that's just basically how it works. So now that's how it works in real life, how you are going to see it on the Etherscan. So now what those feeds mean: timestamp, the block, right, the current time the block was mined, block number, the length of the blockchain in blocks. That is how many. So now if you look at it now, this block, yes, okay. This one, if I go back now, previous block, the current block is 1553. So that's what's used as a block height. That means like this is the number of our blocks that has been mined on this blockchain from inception. So this parent hash is the unique hash of the block that came before this. That's what makes it possible that you can reference the previous block to the current block. So you have the transactions, number of transactions included. The one we checked, it has 389 transactions and stuff. So this one you have state root, which is entire state of the system. So that state root includes the account balances, contract storage, contract code, account nonces, and stuff. So that's just it. Is that clear? Is it Fatima that asked that question? Or Ose? Yeah.
Yes, it is.
So, any other questions? The class is really technical.
Hi, sir. So my question is this: how do you become a miner? Because this rewards is so true.
The money is huge. So like on a proof of work system now, for you to become a miner, you need like a very good, you need steady light, constant electricity, you need a constant internet connection, you need PC with high-end specifications so that you can be up to date. Because if you don't have like PC with not when I mean PC now, I mean like computer system, not a laptop, like systems with high GPU, high processing power. Because if you don't have those ones, a system with high processing GPU, you just discover that you are wasting money, you are wasting internet, you are wasting data, and you are not getting profitable because you are in competition with other people. So for you need like those high-end specifications of hardware for you to be able to participate. And the requirement varies for each blockchain. So like if you want to be a miner on Ethereum, you can go to their docs and see like the requirements for you to become a miner. Matilda, is that clear?
Yes, sir, it is.
Okay. Since nobody's any other question, Well, welcome to the life. I know today's class is a little bit more advanced than what last week was. That's how it's going to be. It's going to like get harder as you like progress, but something you can do. So that is it. Try as much as possible to read ahead of classes so that we are all on the same page. That's why I send those materials to you. So you guys should give me a review. How was today's class? How was today's class? Since nobody wants to ask question.
Well, it was good. It's only the gas fee part that was a bit complicated, but the rest I think were a bit explanatory. Like they were clear.
Okay. All right. So for the gas fee,
Today's
you
class
guys,
is actually the okay.
okay, I'm coming. So for the gas fee, you guys should please read up on some of the materials that I share with you guys. So let's say after reading or while you are reading, you have questions that need clarification. Please drop it on Slack. Drop it on Slack, or you can message. You can message me anywhere here. So Matilda, you can proceed. Abi, sorry.
I said today's class is actually the first class that I was able to follow from start to finish. The previous
Okay.
classes, I'm always lost. Like halfway through the class, I'll just be disorganized and like, what are we talking about? But today's class, yes, even though everything is not extra clear, but at least I understand. I know that with further reading, I'll be able to get more info on it.
Okay. All right. Chiamaka.
Okay, today's class was nice actually and very enlightening. I want to ask a question. This one is quite unrelated to the class. I've not been able to go or log into the Slack. I don't know why the link is been blank. It won't send to me. I don't know if you can send the other link, but it seems there's a specific Slack group for the bootcamp, right? I mean, the
Like, I
general
don't
She
understand.
Code
You are
Africa
not seeing the
Slack group.
Web3 Ladies Shecode Africa stuff, the channel.
Yeah, I'm on the SCA, the main SCA channel, but I can't go into any Web3 channel. I don't know. I can't. The link that was sent to me is broken.
You are meant
I'm
to
not able
just
to
have
log into the
access
channel.
to the Web3 Ladies / SCA channel. So if that's where you are, then that's the major one you need.
No, the one I mean is the SCA Bootcamp channel.
On
The
Slack.
SCA Bootcamp channel, the SCA channel, the She Code Africa channel, the general She Code Africa channel.
Oh, sorry. I probably you should speak with others. I don't know how it works. I'm basically here to teach. So as regards like the
Thank you.
Shecode Africa channel, I don't have any information about that.
Please, fellow participants, if you have the link to the Slack group, the Web3, kindly share it in the in-call messages. Thank you.
Okay. All right. You can send. You can. Is this your name on Slack? Or you can drop
Yes, this
message
is my.
on the Slack channel so that they can help you there. And like even people that are not participants, like the moderators can help you on that.
All right. Thank you.
All right. So that's it. We've come to the end of today's class. So you guys should please try as much as possible to read and contact me. Drop anything that's confusing for you so that I can walk you through it. And don't forget, like, share what you've learned today on Twitter, on LinkedIn, and stuff. And that's it for today. So take care, everybody.
Bye. Thank you. Bye.
Yeah.
Bye.
Yeah. Let me stop recording.